Looking at this problem, we do not have a triangle drawn. So let's just look at our information that we have. Angle A is 44 degrees. Angle B is 25 degrees. And side A is 12. Since I know that I have two angles, I can find the third angle of this triangle. And it says round lengths to the nearest tenths and angle measures to the nearest degree. So we're going to be finding the missing sides. We know that we need angle C, and we need side C and side B. Those are our three unknown values. Now, as far as our angles go, angle A plus angle B plus angle C equals to 180 degrees. Angle A is 44. Angle B is 25 plus angle C equals to 180. If you add 44 plus 25, you get 69 plus angle C equals to 180. Subtract 69 from both sides. So therefore, angle C is equal to 180 minus 69 would give me 111. So this is that situation where we have one obtuse angle and two acute. So I'm going to draw us a triangle that has an obtuse angle. And that obtuse angle C is 111 degrees. So here's angle A, here's angle B. The side opposite angle C is side C. The side opposite angle A, which is 44, is lowercase a, and we know that's 12. Angle B is 25 degrees, and the side opposite angle B is side B. So we cannot use trig functions to find the missing parts of this triangle because we do not have a right triangle. So we're going to use law of sine. Okay? Law of sine is A over sine A equals B over sine B equals C over sine C. Now let's fill in as much as we can into law of sine. Side A is 12 over sine of capital A is 44 equals to B. I'm solving for B. I don't have B is equal to sine or B over sine of capital B is 25. Now, I could just stop right there, let that be one proportion, because notice that I have both of my A's. I have lowercase a and capital A. So this is the fraction that I will use in both proportions. Because when I look at this proportion, I only have one unknown, which is B. So I'm going to go ahead and set up another proportion using my A's because I have both A's. 12 over sine of 44 equals to C over sine of capital C, and capital C is 111. So there is my second proportion that I will use to find C. Again, I use the A's because I knew both of these. I use the A in both of the proportions. And then here I'll be solving for B, here I'll be solving for C. So let's cross multiply here. So I have sine of 44B, if I cross multiply, equals to 12 of sine of 25. And I could have had 12 sine of 25 on the left and sine of 44B on the right, same thing. Solving for B, divide both sides by sine of 45. Sine of 44. So B is equal to, use your calculator, 12 times sine of 25 divided by sine of 44. And we're supposed to round the sides or the lengths to the nearest tenths. When we do that, I end up with B is equal to 7.3. So on this particular problem, B is equal to 7.3. Let's solve this proportion. Again, cross multiply. 12 times sine of 111 equals 2. C times sine 44 is C of sine of 44. Again, I could have had those swapped. I could have had this on the left and this on the right. Same thing. I'm solving for C, so let's divide both sides by sine of 44. Divide both sides by sine of 44. So C is equal to 12 times sine of 111 divided by sine of 44. So use your calculator. 12 times sine of 111 divided by sine of 44. And you end up with C is equal to 16.1. 16.1. And again, that's approximation, because anytime you round, it's approximation. So the answer that you would put in the Math Excel for B is 7.3, and for C is 16.1. Again, we must use law of sine because this is not a right triangle, and we cannot use our trig functions and set up proportions unless it's a right triangle.